The ETL pipeline started at 2 a.m., but job B never ran. No error, no alert, the entire batch was stuck because success. Job A stays false when job A is inactive. Let's break down AutoSys job dependencies and conditions, how it works, and the exact mistake behind that failure. AutoSys conditions are like traffic lights for your jobs. They define when a job can start based on other job statuses. The for-condition functions each check a specific aspect of a job's lifecycle. You can combine them with and, or, and parentheses to form complex dependency logic. Dependencies are the core mechanic. The condition string is a Boolean expression referencing upstream job statuses. When all conditions are true, the downstream job becomes eligible. But a critical property, conditions evaluate the most recent run. If an upstream job has never run, its status is inactive, and success evaluates to false, the downstream job blocks indefinitely with no alert. AutoSys provides 4 functions. Success triggers when the reference job completes with exit code 0. Failure triggers on non-zero. Done fires regardless of exit code. Not running triggers when the job is not in running state. Each takes a job name as argument. Here are examples of each condition function and how to combine them. Notice the syntax, the function name followed by the job name in parentheses. You can chain multiple conditions with and or, and use parentheses for grouping. Conditions can reference jobs in other boxes. The reference job must have a unique name across the entire AutoSys instance. You cannot condition on a box name to wait for all children. Instead, condition on the last child job or use done box name, which completes when all children finish. Here's a cross-box dependency. The job generate daily report in reporting box waits for ETL load job in ETL box. The condition references the job name directly, not the box. Ensure job names are globally unique to avoid collisions. Done is often overlooked but very useful. It lets a job run after another job completes regardless of success or failure. This is perfect for cleanup or notification jobs that should always run. Because done triggers after any termination, including kill or timeout, it ensures your post-processing runs reliably. Here are 2 examples using done. The cleanup job and notification job both use done main ETL job, so they run regardless of whether the main job succeeded or failed. This is the safest default for side effect jobs. Not running triggers when the reference job is not in running state. Important caveat, it evaluates true if the job has never run inactive. That means if you write condition, not running app job and app job hasn't been scheduled, the condition is immediately true, the dependent job starts right away. Use self-referencing not running for job serialization. Here are 2 not running examples. The first uses self-reference to prevent concurrent runs of the same job. The second waits for a resource cleanup job to finish. Remember, not running is for concurrency control, not sequential execution. You can build complex dependency logic by combining conditions with and or operators and using parentheses to control evaluation order. AutoSys evaluates left to right, respecting parentheses. There's no not operator. For complex conditions, consider breaking the logic into intermediate box jobs. Here's a real-world complex condition. The final aggregation runs if both ETL and validation succeed, or if a manual override flag is set. Notice how we use an intermediate box to simplify the condition. This makes your JIL easier to read and debug. This is the same issue we highlighted at the start. Here's exactly why that happened. The ETL pipeline started at 2 a.m., but job B never ran. The condition was success, job A, but job A was not scheduled that day. It was placed on hold as part of a calendar exception. Since job A was inactive, never ran, the condition remained false indefinitely. AutoSys does not treat never ran as a failure, it simply blocks the dependent job. The root cause is that success on an inactive job never evaluates to true, causing the downstream job to wait indefinitely with no alert. The misconfigured condition used success for a job that may be skipped or never run. The fix was to change the condition to done, job A. This makes job B run regardless of job A's outcome. Alternatively, we could have scheduled job A with a forced run or used notrunning, with an additional calendar check. The key lesson: for jobs that must always run after a predecessor, even if the predecessor is skipped, use done, or notrunning, with proper safeguards. If job A is inactive, never ran, success, job A never evaluates to true. The dependent job stays pending forever with no alert. Always verify reference jobs are scheduled or use done if the dependency is not strict. A common production mistake is using success for cleanup jobs. If the main job fails, the cleanup never runs, leaving temp files or stale locks. Always use done for cleanup, notification, or logging jobs. Using force strtjob sets the job's status to success, but does not update the condition history. Downstream jobs that check for done, job 1 will find no record of that run instance. Use change status as success instead, and always log force starts. The article mentions exit code in passing but doesn't show its syntax. Use exit code, job N, to trigger on a specific exit code, which is critical for workflows where different exit codes indicate different outcomes. The JIL syntax shown, e.g., condition, success, job A, is standard across AutoSys versions 11x and 12x. However, in very old versions pre-11, conditions used a different format like condition, S, job A. Always verify the version in use. The article mentions term, but doesn't provide a code example. Term, job triggers when a job is terminated, e.g., by sendEvent eKill, which is useful for alerting on abnormal termination. When using global vars in conditions, ensure the variable is defined before the condition is parsed. AutoSys substitutes variables at job start time, so an undefined variable can cause the condition to evaluate incorrectly, often silently. To diagnose dependency failures, first check the condition of the stuck job using autorepq, then verify the status of referenced jobs. If a referenced job is inactive or failed, that explains the block. Also review condition logic for unintended OR conditions that may cause early triggering. Let's run through some common interview questions. Difference between success and done. Success triggers on exit code 0. Done triggers on any completion. Can conditions reference jobs in other boxes? Yes, by unique job name across the instance. What happens with circular dependencies? Jobs deadlock silently. AutoSys does not detect cycles. And a few frequently asked questions. What condition functions does AutoSys provide? Success, failure, done, not running. When should I use done instead of success? For cleanup, notification, or any job that must run regardless of upstream outcome. How does not running behave if the referenced job never ran? It evaluates true immediately, which can cause unexpected early triggering. To recap, always use done for cleanup jobs that must run regardless of outcome. Be aware that success and failure require the referenced job to have run at least once. Pin dependencies to specific run instances to avoid race conditions. And always test your dependency chain with a fresh job history to catch inactive blocking early. Ready to go deeper? Up next, AutoSys calendars and run calendar, then AutoSys global variables, then AutoSys date conditions and run window. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.